Alright guys, welcome to 2.7 Hyperbolas. Here's your warm-up for today. It says, write a short paragraph describing the similarities and differences in the equation of a circle and the equation of an ellipse. So before we start, let's figure out which one is which. Okay, you don't have to give me a short paragraph, you can give me bullet points. Here you have a circle, because you have an R square, and here you have an ellipse. Okay, so there's your ellipse. All right, what do you have that are the same? Well, they both have a center, and that center is H and K. See how they both have H and a K, and they're both square. And notice right here that there's a plus between X and Y square. Okay, and what makes them different is that R square is the same number. So that's how you get a radius and gets a picture that is a circle. Over here, your A square and B square are not the same, okay? And that's why you have a circle that is either flattened, which is compressed, or stretched. And that's how you have an ellipse. So in a circle, the distance around would be the same. In an ellipse, your A and your B are different, okay? So there are some differences. All right. In today's video, I'm going to read over some stuff, but you might want to pause to write down your notes to kind of save us some time, okay? Today's goal, we are going to be able to identify the characteristics of a hyperbola by graphing given an equation. So I might teach it a little bit differently in how to graph, but the notes is also there just to kind of help you. And then we're going to do one problem together to make sure you know how to do it. Okay? All right, so here's your first definition. A hyperbola, it is a set of all points in a plane. Let me see if I can make this a little smaller so you all can see better. There we go. It's a set of all points in a plane such that the absolute value of the difference of the distances from two fixed points is constant. That means they are basically the same. It looks kind of like an ellipse turned inside out. Here are your equations that you need to know for hyperbola with an x-intercept and a hyperbola with a y-intercept. Now notice how it is not a plus, but there's a minus in between them. Okay? So go ahead and write down the formula. All right, with an x-intercept, if you have a graph, here's your x-axis and here's your y-axis. Notice how your x right here is positive. If it's positive, it's going to cross the x-axis. So it's going to go in this direction, like this. And we call that left to right. Okay? If your equation starts with a y, here's your x and your y axes, okay? Notice how your y is positive and your x is negative because that sign in front of it. This, your hyperbola, is going to go up and down. Your end behavior is going to point up and it's going to point down. So make sure you know which way, which direction it goes. Okay, so how does this equation differ from an ellipse? You've got a minus between them. In an ellipse, both of these are positive. And the reason that matters is, like, if you have 1 minus 3 and 3 minus 1, notice how they're not the same answer, because subtraction causes things to be going opposite direction. All right. Here are some key terms you need to know. The word asymptote, it is an imaginary line that a function will get very close to but never touch. In a hyperbola, we're going to draw corner to corner. And I'll explain that to you when we get to the graph. Okay? Your fundamental rectangles are two asymptotes that intersect at the center of the hyperbola and are perpendicular. And just like it says, it's a rectangle. Sometimes it's elongated, sometimes it's compressed. But there's your fundamental rectangle, and I'll show you guys how to draw those as well. All right. Here's the part I'm just going to read through. You might want to pause so you can write the definition and fill in your blank for your notes. Okay? Here are your steps to graph a hyperbola given the equation. First of all, you're going to find the intercept. So you're going to locate the intercepts at a0 and negative a0. If the x squared term has a positive coefficient, or at 0b and 0 negative b if the y term has a positive coefficient. That all depends. Now, this only works if your h and your k is 0 and 0. Otherwise, we have to change it, okay? Find the fundamental rectangles. You're going to locate the vertices of the fundamental rectangles, AB, negative AB, negative A, negative B, and A and negative B. I will actually show you how to do this, but I'm actually going to show you how to graph using an ellipse, because you already have that in your brain, how it works. All right. Now I'm going to show you how to sketch the graph of the asymptotes. The extended diagonals of the rectangles are the asymptotes of the hyperbola, and they have the following equation of plus or minus b over ax. It is linear. It is a line. Okay? And then you're pretty much going to sketch the graph using the intercepts and approaching. Sketch each branch of the hyperbola through an intercept and approaching, but not touching the asymptotes. Determine if they open away from the x or the y-axis. This is where we say up or down, or left to right. Okay? All right. So let's go ahead and practice. So let's go ahead and learn how to find the the intercepts first. Notice the intercept is your a and your b. A is always under x, so A is plus or minus 5. Your B is plus or minus 6, because you take a square root, okay? Now, if it's A, it would be, goes with x, so it would be 5, 0, negative 5, 0. For B, it would be 0, 6, and 0, negative 6. Notice which one comes first, the x squared or the y squared? Which one is positive? It's an x squared. So there's your x-intercept right there. Your turn. Try to find the intercept. Here we go. A under x is plus or minus 8. Your b is plus or minus 4. So A is 8, 0, negative 8, 0, and this would be 0, 4, 0, negative 4. Okay? Notice how the x comes first. So there's your intercept. Let's try this one. Your A is plus or minus 3, and your B is, let me rewrite that, plus or minus 5. So this would be 0, 5, 0, negative 5, and this one would be 3, 0, and negative 3, 0, because your A first. See how your x comes first? That would be your x-intercept. So if you're graphing this, it's going to go up and down. If you're graphing this one, here's your x, it's going to go left and right. See the difference? Okay. Last one. B is plus or minus 10. Your A is plus or minus 4. So this is 0, 10, 0, negative 10. 4, 0, negative 4, 0. Now, that only works if your h and k is 0. Notice how that comes first. So your graph will look like this, up and down. Okay? All right. To find your fundamental rectangle, you got to find out what your A is. A is plus or minus 5, square root of 25. B is plus or minus 6, square root of 36. So your fundamental rectangle is going to look like versions of 5 and 6. So positive 5, positive 6, 5, negative 6, negative 5, positive 6, negative 5, negative 6. Different versions of A plus B. Okay, so if you were to graph that, it would look like this. See how it shapes like a rectangle? That's what it looks like. Okay? All right, your turn. How would you find the fundamental rectangles there? A is plus or minus 8. B is plus or minus 4. So different versions of 8 and 4. 8, negative 4, negative 8, positive 4, negative 8, negative 4. Same goes for this one. This time your A is plus or minus 3. your b is plus or minus 5. So a comes first. So 3, 5, 3, negative 5, negative 3, 5, negative 3, negative 5. So just different versions of that. A is plus or minus 4. Your b is plus or minus 10. Okay? This is just kind of help you graph. So you're going to have 4 and 10. 4, negative 10. Negative 4, 10, negative 4, negative 10. All right, so there you have your fundamental rectangles. Okay, so how would you make a sketch of the graph? Well, let's take a look at this one, okay? Find your center. 0, 0. All righty, so I'm going to be at 0, 0. There's my graph. A is 5, plus or minus 5. B is plus or minus 6. Notice how it's under y and the other one's under x. Since x comes first, your center, okay, your intercept is going to be 5, 0 and negative 5, 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right? To find your vertices, it's going to be 5, 6, 5, negative 6, negative 5, 6, negative 5, negative 6. So it's going to be 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6. So it's going to be right there. And right here. And then 1, 2, 3, 4, 5, 6. So right here and right here. And there's your fundamental rectangle. All right. Now notice how your x comes first. Since your x comes first, it's going to use these intercept. And there you have your hyperbola. Okay? And that's how you graph. That is if you use the method that is taught with this. Now I'm going to show you how to do it using your ellipse because you already know how to use your ellipse. Okay? So let's take it from here. Guys, ready? Ignore the word U-turn. Your turn. Okay. So what you do is you find your center. And your center is 0, 0. So I'm going to go to my center, 0, 0. Just like your ellipse. A is under x, so it's plus or minus 8. So you're going to go 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Your B is 4. And I know this is a hyperbola because there's a minus. So I'm going to go up 4. 1, 2, 3, 4. Down 4. 1, 2, 3, 4. From your ellipse. Okay? Use your ruler to draw your rectangle. And it's going to go where these corners meet. See that? See how it meets right here? That is going to be your fundamental rectangle. Some of you will use dashes. Some of you will use a solid line. It's up to you. I wish I had not drawn the hyperbola, the asymptote. So I'm going to teach you guys using your ellipse. After your fundamental rectangles, that should be 2.5, I guess. Okay, use your asymptote, and that's going to go corner to corner. That's this line right here that's already been drawn. Now, look at your equation. Do you see how x comes first? So this one's going to go left to right. And there's your intercept right there. Make it draw close to the asymptote as you can. And there you have your part. Okay, I'm going to add one more thing. How to find the foci. Your foci is a squared plus b squared. So it's going to be 64 plus 16, okay? Use your calculator. 64 plus 16, and that comes out to be 8.9. Notice from the center, you're going to go in the direction of your hyperbola, and you're going to count 8.9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Almost right there, and there's your foci. 1, 2, 3, 4, 5, 6, 7, 8, almost 9, and there's your foci. Okay? That's it. So it's easier if you would use your ellipse. All right. Let's do another one together. You guys ready? I wish I didn't have that line drawn on there. I forgot to take that off. That is my fault. Okay. So, let's take a look at this one. Find your center. 0, 0. Okay. Your A is 3 because it's under X. Here's your A. Your B is plus or minus 5. All right. So A is 3, 1, 2, 3. 1, 2, 3. 5. 1, 2, 3, 4, 5 from the center. 1, 2, 3, 4, 5 from the center. And there is my box. Rectangular box. Okay. And then I'm going to draw my asymptote, corner to corner. So you draw your box. Connect your asymptote. Okay. Look at your equation. It's going to go up and down. Why? Because the y comes first. So here's going to be your intercepts. So I'm teaching you the ellipse. Okay? How do you find the fundamental rectangle? You found it. Now, if your foci is square root of 25 plus 9. What is 25 plus 9? I have no idea. Comes out to be 5.8. Goes in the direction 1, 2, 3, 4, 5.8. Bye guys, I'll see you tomorrow, Wednesday. Bye. All right, and there you have your foci. Would you leave my door open, please? Thank you. Yes. Okay, so you guys can try that one on your own, but we're going to do one problem together. Go ahead and try that one. This would be 2, 0.
2, 0? Okay.
Yeah,
So
remember H is 0. This one's -1, -1. Yeah.
Okay.
All right. Okay. Now let's finish this real quick. Okay. Your A is plus or minus 4 and B is plus or minus 10. So your center is 0, 0. 1, 2, 3, 4. 1, 2, 3, 4. Remember, I like to keep my X with my B, my A, and Y with my B. 10 and 10. Let's draw our fundamental rectangle. Okay. And then let's draw your asymptote, which I have already drawn. Y comes first, so it's going to go up and down. Bye, Sherlon. And my graph is going to go close to the asymptote as possible without crossing it. Don't ever cross it, okay? Alrighty, where's your foci? Foci is square root of 100 plus 16. Oops, wrong one. Totally wrong. Okay, 100 plus 16, which is 10.7, 10.8. So you're going to go 10, a little bit above, there's your foci, 10, a little below, and there's your foci. Okay? All right. Okay, let's do one problem together. I'm making a video, be just a moment, okay? All right, let's do number 7 together. Okay, you guys ready? Here we go. Your center is 0, 2. Here's your H, here's your K. So 0, 2. Your A is 5. So left 5, right 5. Your B is plus or minus 3. So up 3, down 3. Draw your fundamental rectangle. I like to do dashes, but some of you will probably do a pencil and do a line. Okay? Connect your asymptote corner to corner. Don't be stingy. Make it go through the graph. Okay? It's going to help you graph. That's all it does. Alrighty? Your y comes first, so here's going to be your intercepts. Sketch it close to the line as possible. Grayson, I think you have room in your same spot, honey. Maybe not. You can just take that seat right back there, hon. Yeah. Yeah, that's a good one. There you go. Okay. To find your foci, let's find our foci. It says identify the vertices. So here are my 4 vertices. These are the corners. Will you close the door, please? So what is this vertices? This is 5, 5, 5, -1. Will you shut the door, please, David? Right here is -5, 5, -5, -1. Okay? Foci. So there's your vertices. So your foci is going to be square root of 9 plus 25. So C is equal to square root. Oop, let me see if you can see better. There we go. That's clear. Square root of 25 plus 9, 5.8. Since it's going up and down, I'm going to go up 5 from your center. 1, 2, 3, 4, 5.8. There's your foci. From your center, 1, 2, 3, 4, 5.8. There's your foci. Okay? And that's what you guys are going to have to do for number 7. Good luck. Thank you. All right.